Hi, my name's Justine McGillivray and I will be speaking about integrating human factors into bowtie analysis of major accident events and major incidents. In the brief session today, I'm going to cover what is a bowtie analysis, where human factors sits in the bowtie analysis, the role of human factors in controlling risk, and reviewing and monitoring human factor controls. So firstly, let's look at what is a bowtie analysis. Bowtie analyses are often used to show the possible pathways through which a hazard may lead to a major accident event or major incident, and the controls in place to stop these pathways eventuating. Each diagram is associated with a specific hazard and a single top event. A top event is one of the ways in which the hazard could be released. There can be multiple top events for a single hazard. Threats are events that, if they are not prevented from doing so, are likely to lead to the top event occurring. Controls are the defences against the threat. On the left-hand side of the bowtie, they reduce the likelihood of the threat leading to the top event. On the right-hand side, they prevent a top event, if it did occur, from leading to the consequences. Sometimes controls on the left-hand side are referred to as control measures, while those on the right-hand side are referred to as recovery measures. Controls can be technical, that is engineered, or organisational systems or related to human performance, such as training and competency. Degradation factors are things that could cause a control to fail. And this is where human factors comes into play, as human factors is considered a degradation factor, not a threat, because human factors alone should not be capable of leading to a top event. Degradation factor controls are things that are intended to prevent the degradation factors from interfering with the functioning of that control. Sometimes the terms barriers and safeguards are used to categorise controls. Barriers are controls that are assessed as being sufficiently robust, reliable, independent and effective, which means they can be relied upon as primary control measures against incidents. A barrier is a physical control, that is, a measure that should physically prevent or mitigate the risk. Safeguards are also a type of control that support and underpin the availability and performance of barriers. Safeguards cannot meet all of the criteria to be a barrier. In this sense, safeguards can be degradation factor controls in a bowtie analysis. Here is a simple example to explain these concepts. If you were this person in the green circle, would you rather be behind a firewall or behind the danger sign? Which control will physically hold back the fire? A firewall or fire barrier is a physical control, as they can be designed to hold back explosions, fires, shrapnel, and withstand extreme wind loads. Signage which warns people in their vicinity that they are in a flammable area is a safeguard. Signage cannot physically prevent the fire. However, it supports the other barriers by reminding workers they are in a flammable area and no hot work is permitted. A significant aspect of any risk assessment is considering the role of human factors in the prevention and mitigation of a top event. However, their inclusion in bowtie analyses is generally not done well. This is because human failure is often treated as a generic threat and focus is given to putting barriers in place to try and stop these failures from leading to the top event. And if we consider the 5 principles of human performance, then this is problematic for 3 reasons. Firstly, it mistakenly focuses efforts on minimising risk of human failure to prevent and mitigate the risk of a top event. This focus is an error, as human factors alone should not be capable of leading to a top event. The focus should be on identifying the actual barriers and safeguards for the top event and ensuring they are robust enough to withstand any degradation factors, such as human failure. Secondly, by treating human failure as a threat, it gives undue weight to the few occasions in which errors or mistakes significantly degrade barriers and overlooks the fact that there should be enough multiple independent barriers in place to prevent a major accident event or major incident if one barrier is degraded or fails. And thirdly, it overlooks the fact that most of the time work is performed successfully because of human factors and how people will work to avoid undesirable consequences. The solution to this problem is to include human factors as degradation factors rather than threats in the bowtie analyses. This process involves, firstly, identifying and labelling specific human failures as degradation factors. Secondly, understanding how human failure can degrade each barrier. That is, the human failure inputted should be specific to the barrier. It is not enough to use the generic term human failure. Thirdly, eliminate the risk from human factors through design, technology, and engineering controls so far as reasonably practicable. And fourthly, if you cannot eliminate the risk of human factors degrading the barriers, then safeguards should be identified and put in place to minimise the risk so far as reasonably practicable. This includes how human performance can assure or reinforce the barriers to prevent and mitigate the risk of a top event. Human factor controls are typically safeguards as they often do not meet the criteria to be considered barriers. Safeguards for human factors range from local warnings and signs, the design and implementation of alarms and the human-machine interface to control systems, through to job design, operating procedures, hold or checkpoints within safety-critical tasks, and independent verifications of tasks, to the willingness of frontline workers to stop work if they have any concerns over safety. As such, operators should look at the broad range of human factors and their categories when identifying suitable safeguards. So here is a simple example of how human factors can be integrated into a bowtie analysis as degradation factors and safeguards, not threats. The top event is a natural gas loss of containment. The threat is represented by the blue box and its overpressure. Barriers are represented by the orange boxes, and safeguards and degradation factor controls are represented by the green boxes. Degradation factors are represented by the purple boxes. Like all controls, human factor controls should be subject to ongoing review and continual improvement. Examples of possible triggers for reviewing the effectiveness of these controls are internal audits and review processes which identify areas of non-conformances or deviations, changes to plant and equipment that impacts the way work is done, changes in the workforce, new developments in technology and organisational systems that may further reduce the risk of human failure and enhance human performance, and where a near miss or actual major accident event or incident occurs. In summary, human factors alone should not be capable of leading to a top event. Human factors can be integrated into bowtie analyses as factors which degrade barriers. So far as reasonably practicable, eliminate the risk from human factors through design, technology, and engineering controls. And if the risk cannot be eliminated, reduce the risk by identifying and implementing safeguards. This includes how human performance can assure or reinforce the barriers to prevent and mitigate the risk of a top event. For further information, head to the Department of Mines, Industry Regulation and Safety's website. Thank you.